So let's talk about types of errors. We've learned about the ideas of null hypotheses and research hypotheses or alternative hypotheses. Always have to assume and go into a research study and into an experiment. We have to assume that there are no differences, that there are no relationships. So a lot of our research is always centered around the null hypothesis, or trying to prove that there are differences or that there are relationships. So looking at this table, and so knowing that there are limitations in the sample and the population, when we do research, we're prone to make mistakes. And so there are two particular types of errors that we talk about in terms of statistical significance or statistical hypothesis testing. So let's look at the rows first. So this is really what happens in reality, the true nature of the null hypothesis. It's looking at boxes 1 and 2. This is simply stating the null hypothesis really is true. Just looking at these two boxes, this first row. In reality, there are no differences between groups, or there are no relationships between variables. Whereas the bottom row, 3 and 4, this is in reality, the null hypothesis is false. There really are differences between groups, or there really is a significant relationship between your variables. But if we look at the columns now, this is the action you take. This is the decision you come to based upon your study and based upon your results. So looking at the first column, which includes boxes 1 and 3, this is when we accept the null hypothesis. We fail to reject the null hypothesis. We see in our research that there are no differences between our groups, or there is no significant relationship between our variables. Whereas you can also reject the null hypothesis, and this is consisting of boxes 2 and 4, where based upon your research and after you run your analyses, you see, oh look, we do have significant differences, or we do have a significant relationship between our variables. We are rejecting the null hypothesis. We're accepting the research or accepting the alternative hypothesis. So now that we have kind of looked at this table here, let's really talk about 1, 2, 3, and 4 and what these boxes are. So let's start with box number 1. So this is when the null hypothesis really is true in reality. And you, in your research, accept the null hypothesis. You fail to reject the null hypothesis. So in here, good job. You accept the null when it is true, and there really is no differences between groups. Good thing. But, let's say, in reality, there really is no difference between groups, or there is no relationship between variables, but you, in your research, reject the null hypothesis, and you end up accepting the alternative hypothesis. Well, oops, you've made what's called a type 1 error, and you've rejected the null when there really is no difference between groups. So type 1 errors are also represented by the Greek letter alpha, and this is what we mean by our significance level. So let's look at the bottom row, when a null hypothesis is really false, that there really are differences or relationships in reality. Let's say you, also in your research, find that yes, there are differences, and yes, there is a relationship between variables. Well, good job. You rejected the null when there really were differences between groups. This is called power. But if you make a mistake and you actually accept the null hypothesis when it's really true, well, this is what we call a type 2 error. You accepted a false null hypothesis. And type 2 errors are also represented by the Greek letter beta. So type 2 errors are beta, type 1 errors are alpha. And so we can really determine power by subtracting beta from 1. So click on this link for video 1 further explaining type 1 and type 2 errors using some data. And I think hopefully using some numbers it'll help make sense a little bit about type 1 and type 2 errors. Hopefully you watched the video using data on the difference between type 1 and type 2 errors. Here's just another example of it. Okay, so thinking about type 1 errors, this is our alpha error, and our alpha level. This is when you reject the null hypothesis when the null hypothesis is really true. So type 1 errors are also known as a false positive. So let's say, for example, you went out, partied hard, had unprotected sex, and realized the next morning, oh crap, what did I just do? You wait a few days, you go to the pharmacy, and you buy a take-home HIV test. And you end up finding out on that test you're positive for HIV. You freak out. You go to the doctors, and the doctor does a test, and they realize, no, you really are not HIV positive, you're HIV negative. That take-home test committed what's called a type 1 error. That was a false positive. Whereas a type 2 error, which is a beta error, when you fail to reject the null hypothesis when the alternative hypothesis is really true. And this is a false negative. So let's say you buy that same HIV home kit test, and it tests negative. You're like, whew, good to go. Then you go out, party hard again that night, black out, have unprotected sex, but you really find out a month later, 2 months later, you really are HIV positive. Now what just happened? You just went out and had more unprotected sex. So thinking about this example here, type 1 and type 2 errors, we can see how they're different in terms of false positive and false negatives. Just thinking about this, which one of these two errors are you willing to risk having? You're willing to risk having a type 1 error or making a type 1 error compared to a type 2 error, right? If the test said you're positive, you're going to have some anxiety, but really you're not positive, so that's a good thing. Whereas a type 2 error, if you find out, oh, it's a false, I'm negative, you're going to go out there and you can potentially infect other people. This is very, very bad. So hopefully you can get an idea of type 1, type 2 errors. Okay, so let's talk a little bit more about this alpha level. So at the beginning of the lecture we talked about significance level, where really the alpha level is our significance level. And we have control over setting our alpha level. So we set the probability that the null hypothesis is true in the population, given the sample of data we collect on our variables. So when we set our significance level, or our alpha level, at 0.05, this means that we will reject the null hypothesis or accept the alternative hypothesis when all p-values are less than or equal to 0.05. And we'll talk about how we get our p-values, where we get those, and what they mean in the next slide. But really what this means, when we have our alpha level at 0.05, that we are going to reject the null hypothesis only if there's a 5% chance or less that the null hypothesis is true. Because we set our significance level, we can make alpha any value that we want. So another common alpha level that you may see is 0.01. But why would we want to do that? Why would we want to make our alpha level 0.01 instead of 0.05? So let's say you're working on a clinical trial on a drug that claimed to cure cancer. Well, would you want to say that, yes, this pill cures cancer and be pretty confident in it? Or say, maybe, maybe not. Well, think about this idea of alpha level and how it translates to chance of your null hypothesis being true. If we're saying that our alpha level at 0.01, we're saying that we're going to accept the alternative and say that yes, there really is a difference. If the null hypothesis is only true 1% of the time or less, 1% of the time it's going to say no, there are no differences. That's a pretty good claim, right? So we want to be more conservative in our efforts when we do research so that we're not making a bad claim. So a lot of times you'll see in research studies or clinical research studies where you see medical devices or pharmaceutical drugs that the alpha level, the significance level for these types of drugs are much more conservative. The alpha levels are much smaller because they don't want to make the mistake of saying, yes, there really is a cure, or yes, this pill or this device really helps with a specific disease or illness. Well, you want to be conservative in that and not necessarily say that it's going to work for every single person every single time, because then that's just going to lead to lawsuits and malpractice. And so the power, and this is when we think about 1 minus beta, right, a type 2 error, making a type 2 error. This is the opposite of that. So the power of a significance level measures its ability to detect an alternative hypothesis. So the more power you have, the more ability you are to detect that there really is a difference, or that there really is a relationship. And so this p-value, this is the probability that the null hypothesis is true. And in SPSS, you will get a p-value. And that p-value tells you the criterion to accept the alternative hypothesis. So if you get a p-value of 0.05, we're saying that yes, the null hypothesis is true about 5% of the time. If you get a p-value of 0.01, then this is telling you that the null hypothesis is true about 1% of the time. And so p-values are used for all inferential statistics, all of the hypothesis testing that we're going to learn. And it's given to you only through SPSS. So click on the chocolate bars for video number 2, further explaining p-values. After you watch that video, go on to part 2 of the Chapter 9 video lecture.